energy is the ability to work. That's a very important part, right? See, if any sort of energy, we see what kinetic energy is there, right? Chemical energy is there, electrical energy is there, right? Heat energy is there, right? You have got the solar energy, you've got the magnetic energy, right? We've got all this energy which are there, right? So it's a very important part we have to see, that when we see energy, energy is the ability to do work. There are many forms of energy we are looking around, right? Isn't it? Fine. Now, next part is that if you see energy, right? In a closed system, energy can be interconvertible, right? Energy can be interconvertible, right? Means you can convert heat energy to kinetic energy, right? Or you can convert any energy to one another in a closed system, right? Now, in this chapter, when we talk about the electrochemical cells, right? In the electrochemical cells, we talk about what? We talk about the cells which will be converting chemical energy to electrical energy, right? Hmm. First, second, they'll be converting electrical energy to chemical energy. Is it clear, everybody, right? There are two kinds of cells will be coming across, right? One which converts the chemical energy to the electrical energy. Second, it will be converting electrical energy to chemical. It's very crucial for us to know that whenever we are getting any cells, right? This conversion, how does it happen, right? Now, if you see that if you see a spontaneous chemical reaction, now you can write down this part quickly, that more reactive elements, right? You can write more reactive elements, right? More reactive elements displaces, right? Displaces the less reactive elements, right? Less reactive elements from its compound, right? You can note down this quickly, right? Clear to you, right? So we say what? More reactive elements displaces the less reactive elements from its compound. Is it clear to you? More reactive elements displaces the less reactive elements from its compound, right? Means if you see that when we talk about the periodic table, so when we talk about the reactivity series, right? We have got potassium, we have got sodium, we have got calcium, we have got magnesium, we have got aluminum, right? We have got a carbon over here. We have to know carbon, right? Then we have got zinc, right? We have got iron, right? We have got lead, right? We have got hydrogen, right? So it's a very important point we have to nurture, that whenever we are seeing the reactivity series, we have to memorize this reactivity series. That's very important, right? Now, whenever whenever we are doing this, we have to understand that suppose we are taking zinc plus copper sulfate, right? Gives you what? Zinc sulfate plus copper, right? Now over here, see in your A levels, right? In your A level exams, right? These will be tested, right? These will be tested, right? That if you see when we see electrochemical cell, what happens, right? This first thing I'm doing, right? This part, chemical energy to electrical energy, right? Now over here, can you guide me, Tiara, that will zinc displace copper as per this important bit I taught you? More reactive element displaces the less reactive elements from its compound. Its compound. Will zinc
Yes.
displace copper? Yes, it will be, because zinc is higher up in the reactivity series, right? Copper is here. Copper, silver, gold. We're having yes. And just write down this thing. Any displacement reaction will be a exothermic reaction, always, right? And it will be spontaneous also, right? Means delta G will be equal to negative, right? Isn't it? Just I'm connecting the other chapters now quickly, right? Every chapter, the questions which comes in a merge form, right? So zinc plus copper sulfate give you zinc sulfate plus copper. So it's exothermic, and it is what? It is a spontaneous reaction, and delta G is equal to negative, right? Clear? Did you get my point, right? Now going to this thing, if you see when we talk about when we talk about this, right? We have also to understand that if you see any reaction which is spontaneous, right? It will be exothermic, right? Isn't it? So can we do something? Can we convert this? There's a chemical energy given out, right? Can we convert this chemical energy to electrical energy? Think of this. Can we? Yes, we can, right? So it's a very important point we noted, that if you see that whenever we are seeing electrochemical cells, there are two kinds of cells. One is called as the voltaic cell, you write down, voltaic cell, and one is called as what? One is called the electrolytic cell, right? This part you have to master, right? There are two kinds of cells we are having, right? A voltaic cell and electrolytic cell. In the voltaic cell, what happens? The chemical energy is getting converted to electrical energy, right? Fine. Now, in the electrolytic cell, the electrical energy gets converted to a chemical energy. Now, in the voltaic cell, we saw what? A spontaneous chemical reaction happens, right? This thing happens, and this chemical energy can be converted to electrical energy also, right? Isn't it? Now, do you know what? Can you give some examples of some voltaic cell in our houses? Tiara, can you guide me? Or Snigdha, can you guide me? Voltaic cell, or you can also tell me, actually, Richard, that can you tell me some example of this cells in our house? See, can you tell me? Battery, right? The pencil battery we're having. is a voltaic cell we're having, right? Isn't it? Isn't it? Suppose the car battery we are having, right? Car battery, the lead acetate battery, right? In petrol car or diesel cars, right? That is also this is also a voltaic cell we are having, right? Now going to this part, next part is that if you see when we talk about when we talk about this cell, electrolytic cell. What is electrolytic cell? It is suppose a reaction is there, right? Isn't it? Na plus NaCl gives you Na plus Cl2, right? Understood. This is voltaic cell I've discussed, right? That chemical energy getting converted to electrical energy. What kind of chemical energy? A spontaneous chemical reaction is happening, right? That chemical energy is getting converted to electrical energy. They have to know this bit, right? Isn't it? Now, we to see that if you see this reaction, now think that is this spontaneous reaction? What do you think? This reaction? Is it spontaneous?
No.
This is not. So see a very good example. Suppose you're taking a common salt on a plate, right? Common salt on a plate, right?
Mhm.
Will it automatically does it disintegrate into sodium and chlorine gas and chlorine gas is given out? No, no, we don't see this, right? You can do this as an example in your house or some practicals you can do. Keep a sodium chloride on your plate. Will it separating out into sodium and chlorine? No, it's not. So this is a non-spontaneous chemical reaction, right? Isn't it? Please try to write down everybody, please, huh? Delta G, if it is negative, right, Richie, everybody write down this. Delta G, if it is negative, it is spontaneous. Delta G, if it is positive, it is non-spontaneous. You can write down this, right? Clear, everybody? Delta G is it negative, is is spontaneous. Delta G is positive, it is non-spontaneous, right? So any non-spontaneous reaction, right? NaCl gives you Na plus Cl2, right? Now, can we force this chemical reaction to happen? Can we force it to happen, right? Can we force this reaction to happen? No, we cannot. But yes, we can make sure that this reaction happens by passage of electricity, isn't it? Just I'm just correcting my words. I lost my concentration just. This is a non-spontaneous reaction, right? This does not happen on its own, right? But we can force this reaction to happen, right? By what? I'm correcting myself. We can force this reaction to happen by passage of electrical current, right? Isn't it? Now, the cell where we do this reaction, right, is called as what? Electrolytic cell. In the electrolytic cell, what we are doing? We are forcing electrical energy or we are forcing electricity or electrical energy and forcing this non-spontaneous reaction to happen. Is it clear, everybody, right? So in an electrolytic cell, what happens? We are giving a electrical energy and we are forcing the chemical reaction to happen, right? Na plus Cl2, right? It gives you like that, right? Clear till here? It's clear to you? So in an electrolytic cell, what we do? We are giving a electrical energy and we are that is giving out that's giving out chemical energy, right? Isn't it? This is clear to everybody, right? So it's a very important point we have to nurture, right? Now going to the next part, right? If you see when we talk about when we are to talk about this reaction, right? You have to also understand that in any cells, right? In any cells, we have to have what? We have to have electrodes, right? That's very important, right? We have to have electrodes, right? Electrodes, right? Now, what are electrodes? You have to understand. Electrodes are conductors of electricity, which introduces the electric current in the non-metallic part of the circuit. See, I'm just giving you, right? Those who have got physics will be helped by this. So what are electrodes? Electrodes are those which introduce electricity in the non-metallic part of the circuit, right? This is a electrolyte, right? We're having, right, a solution. This is a non-metallic part, right? Clear? So what are electrodes? Electrodes are conductors of electricity. Usually we think that graphite will be taken, graphite or carbon electrodes, right? Or platinum electrodes, right? Or you can have reactive electrodes also. These are non-reactive electrodes, right? Non-reactive electrodes, right? Platinum, graphite, carbon, right? Non-reactive electrodes, isn't it? We can also take reactive electrodes also. That also is there. But what are electrodes? Electrodes are those which introduce electricity in the non-electrolyte part of the circuit, right? Now come to the next part, right? If you see that when we talk about when we talk about this, right? The electrodes can be of two types, right? Hmm. Electrodes can be of two types. You have got cathode. Hmm. We have got cathode. We have got anode, right? Isn't it? Now over here, Tiara, can you guide me that what is in the cathode? What kind of reaction happens for both electrolytic cell, electrochemical? Sorry, both the voltaic cell. and the electrolytic cell? Can you guide me?
In the cathode,
Did I teach you a rhyme? Right. Just take the Zoom chat and everybody can send me a message. What happens in the cathode for voltaic cell and electrolytic cell? Both the cell, the same kind of reaction. I'm giving a hint. Does reduction happens in cathode or oxidation happens in anode? Right. Or oxidation. I told you a rhyme also earlier that I've got some colored pet in my house. Right. Just remember that rhyme. Right. Yeah. Mm-hmm. Yeah. No, pet, cat. What is the color of the cat? I've got a cat. I love cats. Yeah, I die for cats. Yes. So I told you, na, that I've made a rhyme for my students. Yes. Can you recall, Tiara? I told you that I've got a cat. I have got a cat, but I told you that I've got a red cat in my house, red color cat. Can you recall that, right? You also learn that,
yeah.
okay, remember that I've got a red cat in my house. It's very easy to learn that I've got a cat, red colored cat, right?
Mm-hmm.
Means orangish cat, suppose, red colored cat I'm taking. What does that mean? It means that reduction happens very good, Richard. Amazing, Richard, right? Reduction, amazing, Richard. I'm letting you in a clap, right? Yes, Snigdha, wonderful. Fastest finger is Snigdha, Tiara. Anyway, thank you so much, Richard. Very good. Everybody has learned the answer, right? Reduction happens in cathode, right? Is it clear? So we write reduction, right? Is it clear, everybody? Reduction happens in cathode only. Voltaic cell as well as electrolytic reduction happens in cathode, right? Now, if you see when we talk about, yes, Richard, very good. And what happens in the anode? We see oxidation happens. You can write down, right? Let's write this. That will be better. In I can write like this so they can understand the same kind of reaction happens over here. So here you go. I'm writing reduction, right? Like this, right? Is it clear? Same, right? Now come to the part. If we see when we see a voltaic cell. Now can you just go to the Zoom chat quick? What is sign of cathode in the voltaic cell, right? The sign of the cathode in the voltaic cell and the sign of the cathode in the electrolytic cell is opposite, right? Just a hint. What is the sign of the cathode in a voltaic cell? Think. The sign of the cathode with the fastest finger. Okay, wonderful. The sign of the cathode is positive, right? Positive, right? Tiara, Snigdha, very good. Richard, everybody has answered, very good. So positive, right? It's positive in the cathode, right? And negative in the anode, right? Just this bit you have to know, right? In the electrolytic cell, we see what? The sign of the cathode is negative, right? In the cathode, in the electrolytic cell, right? Yes, thank you so much. Thank you so much. So over here, the cathode will be negative, anode will be positive, right? This bit you have to know, right? So in the both the cells, see reduction happens in the cathode and anode oxidation happens, right? So it's very important information we have to learn, right? Isn't it? Now going to the next part, right? Going to the next part that if you see when we talk about when we talk about these cells, right? We have also to understand a very important part that in the voltaic cell, what exactly do we do, right? What exactly do we do? We learned that in the voltaic cell, a spontaneous chemical reaction is happening, right? And this chemical energy is getting converted to electricity, right? By somehow, right? Isn't it? Now, how do we do it, right? Now, see, if you see, suppose we are taking this, if you want to take a photo, you can do it, right? That will be it. Fine. If you want to take a photo, please take a screenshot. That will be very important, right? See now if you see that one when we are going to this part, right? Suppose I'm taking a voltaic cell, right? Suppose I'm taking this reaction, right? Zinc plus copper sulfate, right? Gives you zinc sulfate, zinc sulfate plus copper, right? Is it clear, everybody, right? Suppose I'm taking this reaction. Zinc plus copper sulfate gives you zinc sulfate plus copper, right? Fine. Is it clear? Now, Now, if you see that, if we take this reaction in a single tank, right? If we take this reaction in a single tank, what happens now? I'm putting the oxidation numbers, right? We did oxidation numbers also, guys, in the last session. See, 0, sulfate is -2, so this will be +2. Zinc sulfate this is -2, this is +2, this is 0, right? So what is happening to zinc? Zinc is going from 0 to +2, see? Is it clear? 0 to +2, right? Fine. 0 to +2, right? And copper is going from where to where? Copper is going from copper 2 plus to copper 0, right? See? +2 to 0, right? Isn't it? Fine. So over here, 0 to +2. Now what's happening over here? Can you guide me, Tiara? 0 to +2 is what? Reduction or oxidation? Tiara, what is
Um,
this? Loss of electrons or gain of electrons? First tell me. 0 to +2 is,
gain
tell
of
me.
elect
Loss of
loss of
electrons and
electrons.
loss of
Sorry.
electrons. Right?
Yeah.
You have to know that. See, good that you're doing that. That if you're seeing that 0 to plus 2, right? When the positive number increases, right? There's a loss of electrons, right? So we write loss of electrons, then we write oxidation, right? Then we write Ra, reducing agent, right? Is it clear? Understood? Get my point? 0 to plus
Mhm.
2 is loss of electrons, oxidation, and reducing agent, right? Clear, everybody? Fine.
Mhm.
So that's a very important part we have to know, that if you see that when we see this, when we see this reaction, right? We can understand, right? So she can understand. Just 1 minute, right? Okay. Now going to this thing, now we will see that when we are seeing this is oxidation, and we write Ra, right? Isn't it? Now see what's happening over here. Plus 2 to 0, right? So plus 2 to 0 is what? Can you guide me, Richie? Or everybody try to take the Zoom chat and tell me plus 2 to 0. It's gain of electrons or loss of electrons? Please take a WhatsApp and sorry, Zoom chat plan. What's happening over here? Gain or loss of electrons? Okay, okay. So if you see that when we are seeing plus 2 to 0, right? Wonderful. Everybody's right. There's a gain of electron, right? Fine. And reduction is happening, right? Fine. We know this, right? We know this reduction is happening, right? So it's a very important portion we have to learn, that if you see that when we're seeing any reaction, right, we can also understand, right, that how the movement is happening. Now see, if you take this reaction in the electrolytic tank, right, what happens over here? If this take this reaction in the electrolytic tank, what happens? The zinc, right? See the zinc you have taken 0. This is plus 2, right? If you take this reaction in the electrolytic tank, zinc will be zinc will be doing what? Zinc is, see over here, this is plus 2, this is 0. So zinc is transferring the electron to copper in the solution, right? It's transferring the electron, right? But can we do something such that the zinc and the copper will be connected by a wire, right? Connected by a wire, right? And the electrons will be moved through the wire, right? Isn't it? Fine. Can we do something where the zinc is connected to copper with a wire, and the electrons can be moved, right? And those who are having physics will be understanding this thing. Tere, can you tell me that if electrons are moving in a wire, what is it called? What does it generate? Can you tell me? Do you get my point? What I'm saying to you? If
Yeah.
electrons are moved in a wire, what does it generate? Right? It generates what? Tell me. Anybody take the Zoom chat and tell me.
Um,
Tell me. Or anybody take the Zoom chat and
sorry.
tell me. Did you
Is
get
it
my
current?
point? Did you get my point? What I'm saying to you, that
Yeah.
in the solution, if you take this reaction, zinc will be transferring electrons to copper within the solution. Agreed? Dear, agreed.
Hmm.
This point is clear. Is it clear to Richie? Is
Yeah.
it clear? Yeah. If you're taking zinc and copper sulfate, zinc is transferring the electron within the solution to copper. See? Can we do something? Can we make a system where the zinc transfers this electron through a wire? And flow of electrons in wire is called as what? Flow of electron is wire called as electricity, right? Is it clear? Electricity. So we can write a lamp over here. Did you get my point? Did you get my point?
Hmm.
Is it clear, Richie? Tiara, is it clear to you? Tiara, got it?
Yeah.
What's happening?
Yeah.
That the zinc is transferring the electron to copper, right? Thank you so much, Snigdha, right?
Hmm.
Wonderful answer you've given. So if you see that zinc is transferring the electron to copper within the solution, can we do something that the zinc transfers the electron through the wire, right? And this comes to the copper? Yes, we can do it, right? We can do it. So this system we have to take. For that reason, what we do, is it clear to Richie that we are doing some important scientific method where we transfer this electron from zinc to copper through a wire. Flow of electrons is electricity, right? And we can connect a bulb or whatever, a fan, and run. What we do, we take two half cells. Is it clear? Understood? We take two half cells, right? We dip zinc in zinc ion solutions. We take copper and we dip copper in a copper ion solution. Is it clear, everybody? Right? Fine. This is clear to you, right? We take zinc and dip it in zinc ions. We take copper and dip in copper ions. Right? Clear? Do you get my point? Right? This is clear. So now over here we have to see that when we connect them through wire, right? Then you'll be seeing that a voltmeter, if you place, it will be showing current, right? So this is very important, that we have to make sure that we are taking two half cells. In a voltaic cell, there are two half cells. How can you catch that is a voltaic cell or an electrolytic cell? A voltaic cell will be having two half cells. Is it clear? Two half cells, right? Clear? Do you get my point? Whereas in a electrolytic cell, you'll be having one beaker only. Is it clear? Only one beaker. Did you get my point? Only one beaker will be getting, right? And we are putting the electrodes. Everything is clear. Tiara, did you get this point? Snigdha, is it clear?
Yeah. Mhm.
Richard, is it clear? Richard, you're very shy, very shy. Please tell me, Richard, are you? This is okay for you, huh, Richard?
Yeah.
Right? Thank you so much. Right now, we're taking two half cells because we are forcing zinc to transfer the electron through the wire. Right? This is the voltaic cell. Right now we have to know some definitions. Right? The first definition we have to understand is what? The first definition we have to understand is that the thing called as standard cell potential. Do you know what? When we write H0, G0, delta G0, entropy is to the zero. We have got H also, right? Without zero, or G also without zero, S also without zero, or E cell also without zero. What does the zero stands for? Please go to the Zoom chat, everybody. What does zero stands for? What does zero stands for? What does it mean? We have got E cell also without zero, or some books we are having this slash also. What does it mean? And if you know that, what does it mean? Can you tell a little bit of details? What does it mean? I'm asking you one by one. What does it mean? What does zero means on top of the everybody's head? Enthalpy on top of the head, zero or slash, G zero or slash, S zero or slash. Do one thing, Snee. You just open the electrolytic cell, right? Sorry, electrochemical cell. Sorry, past
Mhm.
this topic wise past paper, please. Um, see over here. Yeah, perfect. What does zero stands for? Zero stands for standard conditions, right? This is clear. Standard condition, right? What does standard condition tells you? Standard condition tells you it is 100 kilopascal, right? Is it? Please write down 100 kilopascal. Is it clear? Standard condition means what? 100 kilopascal pressure. The temperature should be 298 Kelvin. Guys, write down this standard conditions. Isn't it? Isn't it, Tiara? Did you see delta is zero written, right? Something like this, right? Delta is zero. So it tells what? 100 kilopascal. Standard conditions. What does zero tells you? Right? Please guide me, Riche. Standard conditions. 100 kilopascal, 298 Kelvin. And if there is a solution you're taking, you have to take the solution at 1 mole per decimeter cube, right? Clear? Is this clear to everybody? Understood? So standard condition is good. I'm covering all bits, right? That okay. So what does zero stands for? Standard conditions, right? 100 kilopascal, 1 mole per decimeter cube, right? And if you have got any solution, that should be 1 mole per decimeter cube. Temperature is 298 Kelvin, right? Now we have to come to is it clear to everybody what does zero stand for? Standard conditions. We are doing this experiment under standard conditions. Whenever you are writing a thesis, you write delta as zero, all the chemical fraternity across the globe will be understanding, hey, okay, that actually Richard has done this under standard conditions, right? So they will be by default understand by this sign, right? Now going to this thing now, if you see when you talk about the thing called as standard cell potential, right? What a standard cell potential tells you, right? I'm just quickly going over that 1 minute. What a standard cell potential tells you, right? Now, standard cell potential is what? Standard cell potential, you can tell that it is standard cell potential is the voltage, right? Is the voltage obtained when two half cells is joined under standard conditions. Is it clear? I'm going a little bit slow, right? What is standard cell potential? Standard cell potential is the voltage produced when two half cells are connected under standard conditions, right? Clear? Everybody's clear? What is standard cell potential? Standard cell potential is the voltage when two half cells are connected under standard conditions, right? Is it clear? Understood this part, right? Now if you see that when we consider that the standard cell potential, right, when two half cells are connected under standard condition, right, isn't it? So that's a very important point. You have to understand that if you see that when we utter the word E dot cell, right, it is actually it is a resultant of the two half cells, right? The two half cells will be having its own electrode potential. You write down this tricks, right? Electrode potential, right? Fine. This one will be having an electrode potential, right? The electrode potential. So E dot cell will be equal to what? E right hand side minus E left hand side cell, right? Clear? The electrode potential of the right hand side is the cathode, right? Hmm. And E left hand side there is the anode, right? We are having, right? Clear? Did this bit clear to you all? Richie understood what is E dot cell? E dot cell is the combination of the electrode potential of the two cells, right? Differential value, whatever. Is it clear, everybody? Snee, is it clear?
Yeah.
Clear, is it clear? Thank you so much. This partner is a very tricky part. See, maximum students will be omitting this chapter, will be running over this chapter, right? Or giving less time. So E dot cell is the resultant of the two electrode potential. You have got a electrode potential be getting in this cell, right? Two half cells is the resultant of it, right? Now understand that when we want to measure the electrode potential, right, of any cell, right? When you want to measure the electrode potential of any cell, right, we cannot measure it in standalone conditions. Understand this part? We cannot measure it. We cannot measure the electrode potential in standalone conditions. Is it clear? We cannot measure it, right? We cannot. Do you get my point? We won't be able to measure the electrode potential in standalone conditions, right? We won't. What do we need? Because you know why I'm telling you. Do you know what? You have understood, right? You just learned that in the cathode, red cat happens. That it will be reduction happening at the cathode, and anode oxidation happens, right? Fine. So a standalone electrode potential you won't be able to find out unless and until you're connecting that electrode to another half cell, right? Then only you can find out, right? So what to do? What to do? In order to find out the electrode potential of any half cell, right? What we do? We have to connect it with a standard hydrogen electrode, right? Isn't it? What is standard hydrogen electrode? Now, standard hydrogen electrode is also called as She, right? In many question papers, you might see that SHE is given, right? That what are the essential features of She, right? Means standard hydrogen electrode, right? Now, if you see that when we call something as standard hydrogen electrode, right? What is the standard hydrogen electrode? In the standard hydrogen electrode, you have to understand that we are pumping hydrogen gas, right? At standard conditions. Standard. What are standard conditions? 100 kilopascal, 1 mole per decimeter cube, and the temperature should be 298, right? The standard hydrogen electrode will be used to measure the standard cell potentials, right? Sorry, standard electrode potentials, right, of the half cells. Clear, everybody, right? We cannot measure the electrode potential, right? Isn't it? We cannot measure the electrode potential, right? Singularly, electrode potential we cannot measure, right? So we have to use the and the hydrogen electrode, right, to measure it. What are the things which are going over here? We are taking we are taking hydrogen gas, right? We are bubbling hydrogen gas at standard conditions, means 100 kilopascal, 298 Kelvin, and we're taking the solution at 1 mole per decimeter cube, right? This concentration we're taking, right? Isn't it? This is a standard hydrogen electrode. Now the standard hydrogen electrode, the reaction will be what? H plus E gives you H2, right? And you can balance it like this also. You can put a half over here, right? That also is done. Or you can put 2 over here, right? Also you can balance like this, right? Isn't it? 1 H2, right? Both the ways goes. But you have to learn that standard hydrogen electrode has got a electrode potential, right? Has got an electrode potential of 0. Is it clear? This is arbitrarily assigned to the standard hydrogen electrode, right? Fine. Okay. So that's the thing we learned about. What we learned about the difference between voltaic cell, electrolytic cell. We learned about that. Why do we need two half cells in a voltaic cell? We learned about the cell potential, right? Standard cell potential. What are electrode potential? Now we have gone to that. How can measure the electrode potential, right? And we learned about the standard hydrogen electrode, right? So thank you so much. I'm just coming after a